Hello, my name is Joseph Earley, and this is my submission for CS1800 Discrete Structures Final. What we are doing here today is proving that 9 raised to the power of n minus 1 is divisible by 8 for all numbers where n is greater than 0 using induction. Now to start, we really have to ask, what is induction? And that is really easy because it's just a type of reasoning or another way of thinking. But you're probably saying to yourself, I already know how to think. I see something happen in the world and then I react to it and make observations. That is actually deductive reasoning, where you see a general idea or truth like it is raining and I am sad because of it. You observe other things like, it's dry under this umbrella, and come to a conclusion that if I want to stay dry, I should wear an umbrella out with me when it is raining. Now, inductive reasoning is slightly different because you start with a single observation, make analyses off these observations, and then create a theory based on what you see, right? So using this bag of coins will probably explain it a little better. There's 50 coins in this bag. I pull out a single penny, and then that's all I know. That is my base case of 1 penny pulled out of the bag. I then take out 19 more coins that are also all pennies. So using the data that I know, I make the assumption that there are only pennies in my bag of coins. This isn't necessarily true, it's just an assumption that I've made. So we are gonna move on to what our actual goal is. Proving 9 to the n minus 1 is our theory. So we are trying to do that. That is our goal and not the start. So where do we start? With a base observation. Since the first time n is greater than 0 is when n is equal to 1, we'll use that as our base case, right? So this kind of makes sense, right? 9 raised to the power of 1 is just 9. And 9 minus 1 is the number 8. 8 is divisible by itself, so we have proved this first case. This is a observation that is true, right? For this formula, when 9 to the 1 is n is equal to 1, we know it is divisible by 8. So our next step is the analysis portion, where we're just going to take some assumption that some number k, which is equal to n, is true, which is just us saying 9 raised to the k minus 1 is equal to some number that is divisible by 8, that 8. The reason this is useful for us is because we can isolate this 9 to the k, which we will use in our next step. But I'm going to kind of show you this next step a little for it. K can be any value, right? So let's just assume it's 2. We can prove that our m will be 10. So 9 squared is 81 minus 1 is equal to 80. 80 divided by 8 is 10. So we've shown that this is some p of k that is true. Now we use that p of k that we have shown is true to show that p of k plus 1 is also true. So basically saying 9 raised to the power of k plus 1 is equal to a number divisible by 8. We can do this by saying 9 times 9 to the k minus 1. Now the reason we can do that is just how powers work. 9 squared is 9 times 9. 9 cubed is 9 times 9 times 9, or 9 squared times 9. So this 9k that we have found over here is simply 9 to the k plus 1 is now this 9 times 9k, or 9 times m8 plus 1. Now using this, we can just solve and do some basic math, right? This 9k becomes this value that we showed up here. Put it right there. Do some basic math till we get here, and you have 72m plus 8. Now this, we can factor out an 8 and show that 9 to the k plus 1 minus 1 is equal to some number, in this case, 9m plus 1 times the value 8, which means this is divisible by 8. Now, this is kind of useful because we can go back to our k equals 2 from before, where our m equals 10, right? So 9 to k plus 1 is just 9 cubed minus 1. Now, setting this m equal to our 10, we have 9 cubed minus 1, 8 times 91, right? 9 cubed is 729, and then 8 times 91 is 728. Minus our 1, we've shown that 728 equals 728. So using that, we just proved that k plus 1, or 3, is true. So since we proved that is true, our reason is done because set k equal to 3 now. That's 4 is true. Now 5 is true, and 6 is true, and all numbers greater than 0.